STEM Adventure Revision Notes, OCR A-Level Physics. Work, Energy and Power. The key to this topic is understanding the principle of conservation of energy. The total energy of an isolated system always remains constant. Basically, energy needs to come from somewhere and needs to go somewhere. It can't just appear or disappear. One way in which we can change the amount of energy an object or system has is by doing work. Work is done by applying a force through a distance, giving it a push. Work can be considered to be the same as the energy transferred. A typical example of this is giving an object a push to make it go faster. So we do work and the object gains kinetic energy. Remember that the kinetic energy equation isn't given in the data book, so needs to be memorized. Another typical example is lifting an object up through a height. Here the work is done to increase the object's gravitational potential energy. This is another equation that is not given in the data book. These three equations are critical to many problems and will be tested on extensively. Spend some time to memorize them now. The derivation of the kinetic energy equation must be understood and remembered. Here we start with one of the Suvert equations. Final velocity squared equals initial velocity squared plus 2 times the acceleration time, the displacement. We can rearrange this as shown. Then multiply both sides by mass. Remembering that resultant force equals mass times acceleration, we can substitute in to give force multiplied by displacement, which is the same as work done. Finally, if our initial velocity is 0, we have kinetic energy equals a half mass times velocity squared. One of the most widely encountered situations for the kinetic and gravitational energy equations is for objects falling or moving from one height to another. For these situations, the important thing to remember is that the gravitational potential energy of the object will be transferred to kinetic energy as the object falls and speeds up. This is irrespective of the path taken. If there is no friction or drag, the maximum kinetic energy of the object just before it reaches the floor will be equal to the maximum gravitational potential energy it had at its maximum height. If friction or drag is present, then some of the gravitational potential energy will be transferred to thermal energy. An object moving upwards is just the reverse of this. Remembering the power equation is important to this and many other topics. The fact that it is the rate of energy transfer and that the units watts can also be expressed as joules per second are often assumed and enable you to interpret many questions. Lots to remember here. The efficiency of any energy transfer situation can be calculated using the useful energy output and the total energy input. And you might encounter many different types of energy depending on the situation. You will notice on closer inspection that all these are basically due to an object's motion or position in a field. Again, lots to remember here. Don't forget that these and many other resources and games can be found on our website stemadventure.space.